Alright, it's 9:05, so let's start. So let's do the homework. So in the homework he said there is a house and here is the electric bill. This is actually my electric bill. I actually collect them every month. So you can see we use a lot in the winter and we use a lot in the summer because of the air conditioning, right? So this is the load kilowatt hour per month, and this is the number of days per month, so that if we divide this by this become the kilowatt hour required per day, right? So the first thing that you need to do is when you have this guy over here, you would need to write what is so what you need to do is the kilowatt hour per day, and so this would be 137 divided by 31. Okay, and he's asked, and we'll do it for every month. Okay, kilowatt hour per day. Now the question is how many 300 panels are needed to generate that load for every month, and those panels are sitting on a roof. That roof is latitude plus 15. Okay, so the question is, will a 300 watt panel generate every day 300 watt multiplied by 24 hours per day, and that's the kilowatt hour? No, it will not. First, there is no sun for half of the day. Second, it will not run at 300 watt all day long because you are not sending the one sun on it. You are not sending 1000 watt per meter square. And so to figure out how many kilowatt hour is coming from one 300 watt panel every day, what do? We have this calculation that basically say that the kilowatt hour generated, this pencil is weird, per day is the rated power. So it's like the 300 watt multiply by something over 1000 watt per meter square. What is that something? It is the kilowatt hour per meter square per day. So in this case it will be 4.3. Why? Because it's latitude plus 15. Okay, and in the next month we will use 4.7, and next month 5.1, next month 5.2. So as you are going from every month, the kilowatt hour generated per day would be the rated power multiplied by how many kilowatt hour per meter square per day is happening, divided by the standard, which is 1000 per meter square. 1000 watt per meter square. What is the unit that we will get? Kilowatt hour per day. Okay, now one more trick or one more problem here. He said assume 85% combined efficiency of charging, discharging of the battery, and the inverter efficiency and the electric wiring loss. So he's saying you are not even going to get all this. You have to multiply this time 0.85. Okay, so now this is from one panel. So how many panels? You just multiply by n. Okay, and the question is, what is that n? And so that n will have to be equal to, so it's n multiply by, see, I lost my other pen in somewhere, I'll find it. Meanwhile we have to use this. So that n is multiplied by the 300 watts multiplied by the kilowatt hour per meter square per day divided over the 1000, multiply by 0.85. And so we will find this n so that we can satisfy this number. And we do it for every single month, and you find all the n's, and the one with the largest n, that's the one that we will have to buy. Make sense? Okay? So what is the equation again? The kilowatt hour that you will generate per day is the rated power multiply by kilowatt hour per meter square per day divided by 1000 time any efficiency that the system would penalize you for. Okay? The second problem, he said now we want to store, so this is assuming that all storage is basically happening, assume the grid will be used to store or extract energy when the sun is not available. So this system basically say just generate those kilowatt hour and don't worry about when they are being generated and when they are being used. You just need to generate those kilowatt hour, they will go into the grid, and at night when you want to keep using them, they will bring them from the grid. So he just wants the meter to stay at zero. He doesn't want the meter to consume or basically generate more than what you are required to generate. Okay? So this is for a grid connected house. So in the second part, he said, no, we want this thing to have battery, and this battery is not just gonna do day-to-day operation. He wants the battery to store 7 days of operation. Okay, and so for storing 7 days, he's basically doing two things. This is actually what the industry recommend. They tell you when you have a battery back, the standard is to basically, or the recommendation to have 7 days of storage on those batteries. Why doing this? One, in case you have a rainy day, 2 rainy days, 3 rainy days, 4 rainy days, you are in good shape. But really what they are doing is, what? They are doing the discharge depths. They are basically saying, don't buy batteries that just will be eaten every single day, because that will shorten their life. And instead, it's 1/7. What's 1/7? 0.1 something? 1.5 or something? So by having it at that level, the battery basically pack will live way longer. Unfortunately, that means a lot of them, which mean that the price will really go high. Right? So how can I determine how many batteries do I need? I need to divide the load, right? I need to divide the load by how many can I store in each battery. So the daily load is gonna again vary every single month, right? And we will get it by, let's just divide let's get the kilowatt hour per day, right? And actually maybe we should do the kilowatt hour per week, because that's what they want to store, right? Because he wants 7 days of storage. So it will be the 137 divided by 31 multiplied by 7, and the other one is 1025 divided by 28 multiplied by 7. So every month you will find out what is the kilowatt hour per week. This is how much energy you want to store. Now, how much does every battery store? How do I get the kilowatt hour that the battery store? He said it's $200, 12 volt, 100 ampere hour from Home Depot. So 100 ampere hour, if I multiply the 100 ampere hour by the 12 volt, what do I get? Kilowatt hour. No, watt hour, right? So by multiplying the voltage time the ampere hour. He said 12 voltage times 100 ampere hour. What I'm gonna get right now is 1200 watt hour. Divide over 1000 and get yourself the kilowatt hour. Okay, that's how much every battery will store. So if I divide this number by this number, that will tell me the number of battery set I got. And I do it for every month, and obviously the months with the largest storage, which is what, the summer actually, 1372, that's the largest in August. That would be the one that required the largest number of batteries, right? And he said he won the prize for each, for the thing, so he multiplied by $200 for each set. Questions?